Hello everyone, I'm Hao Yuli, and my partner is Shaoting Huang and Zijun Huang. We are going to present our project for EE 542, Internet and Cloud Computing at USC, and we are proud to present our product, Pet Indoor Tracker. If you own a pet, you will have problem to find it at home, and our product will be a solution. Let's watch a short video.
I got a cat named Ginger. You know cats. They love playing hide and seek. Ginger! Ginger! Bro, this is so frustrating. I wish there was an app for this. Oh, I got it! I can use the Pet Tracker. With our product, Pet Tracker, tracking your cat indoor is no longer a problem. With our advanced and refined triangulation algorithms, we can track your pet in your home in real time with no problem. Along with real-time tracking, we also provide insights of your pet. Oh, Ginger, there you are!
Let me introduce some marketing data. As we can see from the chart, the number of the pet owner households has steadily increased from the 1991 to 2024, showing a constant upward trend. These trends provide valuable insights for the business and professionals in the pet industry, which means a huge potential market for our product, Pet Indoor Tracker. As you can see, people are increasingly willing to spend money on their pets, focusing on their food, mental well-being, and hygiene, and overall health. However, when it comes to pet trackers, a product directly related to the pet safety, there is immense market potential. For nowadays, what kind of pet tracker in our market? Let's talk about our competitors. We know the AirTag is very useful in our daily life, but it can only provide distant accuracy within 10 to 30 meters. Obviously, we can't use the AirTag to track pet in your house. Hello is a kind of professional pet tracker based on GPS. We can see the price is extremely high, and we all know that GPS is outdoor use only, and the pet camera is commonly used at home. But when pets try to hide, for example, my cats are crazy about sleeping in my closet, there's no way for a camera to find it. So, as customers, what they really valued as a pet tracker? Let's watch some interviews.
对于这种软件的需求的话，我其实希望它可以首先就是更加续航一些，因为可能有的时候我不在家里，那我又想关注一些它的一些动态，那我担心它会没电啊或者之类的情况。然后另一个就是如果它可以记录一些宠物的一些行动的轨迹，我可能可以更好的知道它在我的房间里，比如说这个时候去到了哪里，下一会儿去到了哪里，这样的，对，可以更好的定位到它。
其实对于我来说，我觉得最关键的是希望在这样的功能的加持下，更希望的是我的猫猫能够很舒适的，然后让我去拥有这样的一项功能。因为我的猫猫的话，它可能对于身上佩戴一些东西啊，或者是佩戴一些帽子啊等等，或者是项链啊等等，它会觉得不舒服。所以我希望这样的一款 APP 它所携带的放在猫猫身上的定位器是更加轻便的，以及在轻便的同时，我会希望它是更加美观的。
好的，谢谢。This slide outlines the workflow and technical framework for our pet tracking app, which integrates IoT device, cloud infrastructure, and a user-friendly mobile interface to provide real-time insights and predictable analysis for pet tracking. It highlights the detailed configuration, the efficient and real-time data transfer capability of our system, highlighting the use of IoT device and wireless communication technologies. On the left side, the image showcases how our IoT device like ESP32, Raspberry Pi, and Android phone send Wi-Fi signal strength and transmit it to near access to nearby Raspberry Pi. These signals are processed and passed on to the connected IoT things for further communication. The riser presents a real-time log for data being transmitted and received by our IoT things. It demonstrates the continuous and reliable exchange of our information using MQTT protocols, ensuring that data is seamlessly integrated into our AWS cloud service processing and storage. which we can see this is our real-time data transform, which sent by the Raspberry Pi on our IoT Thing Android phones. As we can see, it sends the data per second, and we can receive the real-time data transform. Okay, now let's continue. And now, this slide highlights the detailed configuration and implementation of our IoT systems. On the left, we show the physical setup and network architecture of our IoT device. The devices are configured to connect, scan, and transmit signal data to cloud via AWS IoT Core. This ensures real-time monitoring and seamless data collection. On the right, the code demonstrates the real-time data transmission process, where Wi-Fi signal strength data is collected and published to an MQTT topic at 1 second intervals. Below it, you can see the AWS IoT Core successfully receiving and displaying the transmit data in real time, which we can see by this video. This is which you can see when we subscribe the IoT MQTT test client, we can receive the real-time MQTT signal strength data. And this slide illustrates the data processing pipeline, starting from IoT device transmitting signal data through IoT Core, with data stored in DynamoDB and analyzed using machine learning for advanced insights. Our data also go to AWS EC2, which hosts custom algorithms and backend service, ensuring efficient computation and seamless integration with the application. And this is our data received and stored in DynamoDB. As you can see, we receive a lot of items, more than 1,000. This is all the data we can use for machine learning and check our pack activities. And now this slide showcases our front-end user interface, which provides an interactive floor plan to display real-time pet tracking allocations and facilitate intuitive tracking and analysis. Data clustering methods like the Albert method are applied to optimize the analysis, enabling predictions about pet behavior and movement patterns for future improvements. Our workflow provides a seamless integration of IoT, cloud servers, and user interface, ensuring real-time data tracking and monitor for pets.
Once we activate our Wi-Fi signal sender, we can get the constant Wi-Fi signal data from the 3 devices. We can store all the data in the IoT Core, and after processing by the Lambda function, then store to the DynamoDB. After the data processed by our algorithm and is output in the front end, and we can see the pet indoor tracker.
Now, welcome to my part of the project. I'm essentially talking about what algorithms we actually implemented, and which ones are the ones that I'm most proud of. First, temporal synchronization. Essentially, this is talking about the circumstances where we have different timestamps, even if they're sent at the same second, at the same millisecond, the timestamps difference might result in a circumstance where you cannot triangulate. Essentially, I have a workaround basically in my server code to essentially temporally basically cached all the successful attempts of the previous signal level. And I take an average of that and the new one that's basically desynchronized with a different timestamp, effectively minimalize the actual difference of the accuracy problem. And secondly, self-adjusted TX power. And essentially, this is talking about we know the distances between A and B and C, no matter by user input or anything like that. But that's just only one time. And with that information, because we know the distance of AB, we can use this knowledge to constantly or from time to time self-calculate, the RSSI distance and our actually physically known distance to adjust the TX and N as time goes on to ensure the accuracy so that we don't have to just ask user to manually or to manually adjust TX and N ourselves to actually ensure the accuracy of triangulation locating. And this is really what I'm actually proud of, and the temporal synchronization. Thirdly, this is the most important, efficient k-means. I understand that the server code actually runs on Python, which is actually not the most optimal. For our case, we try to minimize the cost for servers. So basically, EC2, we're using the cheapest server. How could I achieve the cheapest, like the best performance on the cheapest server in Python? The reason is no, but essentially we're calculating k-means, using ML algorithm. We cannot write it in C and expect a good memory utilization and performance. Essentially, I wrote this whole piece of code not in Python but in C, and this is actually a pthread library, multi-threaded, self-adjusted K algorithm. Essentially, what it's doing is running in C, better performance algorithm of elbow method, and this actually just essentially determines the optimal K. With this information, we can get the best k-means. And thirdly, best k-means init++, essentially is talking about these algorithms where the for most people known method of k-means plus is actually of time of n squared, but I've actually find a way to implement this algorithm in the running time of n log n. Essentially just not using a double for loop, but essentially just doing like a heap sort, quick sort, and just doing all that in the most efficient way possible. Okay, so now we're going to talk about how we make profits. We devised this subscription model that's similar to the Ring Homes model. Ring is a popular company that was bought by Amazon, and they were pretty successful, for their attempt. We decided to borrow the basic price of for 10 and 20 for each subscription tier. Our cost, essentially right now, our only cost is actually coming from the demo devices, since we're using EC2 and all these functionalities in free tier. But if we're talking about a scalable cost, the actual estimation would be, with all the incoming traffic, the cost would be like $1,400 per month. But with our subscription and our business plan, we're actually able to make profits, if we got like more than 141 users. And that is our first year goal. And revenue needed essentially for that is $1,400 per month to actually cover the cost and to profit. Marketing strategy, we're just gonna use all sorts of marketing strategy and offer discounts for yearly subscriptions, month free trials, and scalable device costs. Essentially, as the product production goes on and on, the production cost is going to be lower since it's streamlined. Essentially, the first year we acquire 200 subscribers, we're going to net profit $600 per month. Second year, 500, we're going to profit $4,000 per month. And that's, pessimistically estimation. So if we're actually, estimate this in a more positive way, we would actually make $7,000 the first year and $43,000 the second year. With that goes on, positively, we're gonna make 13 million the third year, and 25 million the fourth year, and 45 million the fifth year if everything goes right. Thank you so much.